to another episode of Stories from Science. It's wonderful to have you back with us, joining us for all these amazing stories. One that we did in the previous episode was about tragic heroes, and that had a lot of sadness about it. So I thought we'd go a little bit lighter today, and we will look at blunders in science, although that too can have a lot of sad implications. But let's see. Science and technology has brought us such a long way to our modern technological world. You are seeing me wherever you are, all because of science and technology. So how did we actually reach here? So these are some of the stories that we've been sharing, and I am your host, Sharon Hack, that just loves stories from science, and I hope you'll join me too. So if you're not familiar with our format, and I hope by now that you are, I will make a statement, and you will decide whether it's true or whether it's false. And keep a note of it, and we will go through a few stories as much as time will allow, and let's see how you do, okay? And the stories, whether the statements that I make, they will cue us into the stories that we are going to look at. So today's theme is blunders in science. Are you ready? Let's go with the first statement. And the first statement is, the first atomic theory ideas were proposed by Dalton in 1804. Okay, if you're not too familiar with a little chemistry, right, or something like that, so let's just simplify it. The first ideas of atoms were proposed by a scientist called Dalton in 1804. Do you think that's true, or is it false? Did you come across Dalton if you did chemistry along the way anyway? So let's see, what does this cue us to? So today we are all very familiar with the idea that the whole world, all matters, everything at its smallest part is composed of atoms. Where did this notion come from? The word atom itself comes from atomos, which is from Greek origin. So we're starting to see where is our story going. So on record, what you will tend to see is that the earliest ideas of atom came from this gentleman called Democritus, or we could say a Greek scholar, all right? And that was like almost over 2,000 years ago, right? But what happened? But you may also have come across ideas that all things were made up of 4 elements, and that's what people believed for thousands of years. That things were made of earth, fire, and water, and air. And these were the 4 elements that composed everything. But the story gets more interesting than that. And for that, let's go to no other place than India. And this is not very well known. Did you know that some of the earliest ideas of the atom was actually from a scholar in India, and they actually called him Acharya Kannada. And that was because they gave him that name because Kannada, Kan, in Sanskrit meant the smallest particle. And what happened was that as he was walking the streets near a temple, and there were a lot of rice grains that had been scattered for some festival on the ground, and he was picking up single rice grains. And someone commented that, what value is a single rice grain? And he said, this is 1 rice grain. But if I take more and more rice grains, I can make a plate of food and feed someone. And more rice grains can feed the world. And he became interested in the idea of what is the smallest part, and recognizing that the smallest thing could have an influence on everything else. And then he took something like roti and started tearing it apart. And he realized that how many pieces can you tear it to? That it could come to a point that you could tear it no longer. And this is recorded 2,500 years ago. Yes, you all heard me right. 2,500 years ago, before we understood the modern sense of what an atom is, these ideas were put forward by Acharya Kannada in India. He even estimated what size it should be, now, and made the note that it could not be seen by the naked eye, which we know is true. And then when you look at it, he decides that he came up with was about 700 times the modern era size. And that's phenomenal at a time when they had no idea such things existed. But the story takes a twist. So we have Democritus in Greece, we have Acharya Kannada in India proposing these ideas of the atom, all right? And my statement was that the first atomic theory comes from Dalton in 1804. Well, we know now clearly, did you say if it was false or was it true? Well, it turns out that in that sense is false, isn't it? But we are speaking about blunders in science. So what is the big blunder that happened here? Partly you could almost say we owe it to a very well-known scholar and gentleman called Aristotle. So Aristotle was one of the main proponents. There are others also, but he's just one of the key names, with the idea that everything was composed of the four elements: earth, wind, fire, and earth. Right? Earth, wind, fire, and we've got all the different elements, right? And water. Yes, can't forget water. So it's sort of like we've got a liquid, we've got a gas, we've got an energy, and something solid there. So for over 2,000 years, humanity made the blunder of believing that's what everything was made up of. How does that happen when the earliest ideas over 2,000 years ago were on the right track? Well, sometimes I think he or she who can speak the loudest gets heard. And Aristotle had that about him. He had a lot of influence and a lot of things that he had proposed, but let it be known that he was not always right. There were a lot of errors that occurred. So how's that for the first blunder? And you know, it didn't last a month, a year, a decade. 2,000 years, over 2,000 years, when the first ideas of what an atom could have been was disregarded and thought to be something totally different. All right, so that was our first story, which influenced humanity, and you can say set us back for a long, long time until Dalton, of course, in the Western science, and at that point, it started to go on the right track. So, are you ready? Are you ready for our next stories? What could possibly be another blunder? All right, but the statement I'm going to make, you've got to decide, is it true or is it false? Which one will it be? Okay, so listen carefully. It was believed that pieces of cheese and bread wrapped in rags and left in a dark corner could produce mice spontaneously. And you're like, huh? Could you run that by again? Did I mention something about bread and cheese? Yes, I did. Well, the statement that I'm going to make, and I'm going to read it for you again, is it true or is it false? It was believed that pieces of cheese and bread wrapped in rags and left in a dark corner could produce mice spontaneously. All right, so think about whether you think that's true or is it false. And what does this story cue us? What does that statement cue us to? Which story? Well, our hero, again, is none other than the person that starred in the last story. And you may recall I mentioned a scholar, a very, very famous Greek scholar called Aristotle. Yes. So, do you know, about 2,000 years ago, that's about the time Aristotle was around, roughly 2,300 years ago or so, they didn't know how life arose. They didn't know where mice, fish, frogs came from. And they believed that they came from inanimate objects. Right? Today it's like obvious to us, but they didn't know. They believed, right, that once something had vital heat, that's what they called it, that fish and frogs could just spontaneously emerge in a puddle of water. It sounds crazy to us, right? But that statement that I made, and now you know, right, was it something that was believed? It turns out that it actually was true. It was believed that pieces of cheese and bread, if you wrap it and you put it in a dark corner, mice will appear spontaneously. And is it any surprise that this theory was called spontaneous generation? So for how long would people believe that something like this could explain how living things come about? A decade? 100 years? A couple hundred years? 1,000? Are you thinking 2,000? And it's so hard for us to believe because, of course, today we know, right, that that's not true. We know that if you put cheese and bread in a dark corner, it's going to attract mice. That's what brings them there. Not that they are born spontaneously from that rag, but that is what they believed. And this theory was put forward by Aristotle and other supporters, and there were huge debates, again lasting thousands of years. All right? So another major blunder. So you see how we have to be so grateful for where we are in our understanding of science today, okay? So you might be wondering, well, how did they finally get rid of that notion? Well, there was a lot of debates among scholars, and finally the Paris Academy of Sciences got so fed up of it, they offered a prize to anyone who could possibly prove if spontaneous generation, that things just arise spontaneously out of mud, is true or false. And the winner of that prize was, it was the Paris Academy of Sciences, none other than a name you may have heard of, Pasteur. You ever had pasteurized milk? It's his name that goes into that word. So Pasteur actually went and set up an experiment. We won't get into the experiments. Just know that he did this little thing with some vessels and curves in it. And he was able to show that, no, you do not get things spoiling just because of spontaneous events. He was able to show that, you see, at that time they didn't know about germs. And by around the 1800s, things that we couldn't see, microbes that spoil food and things like that. And for once and for all, Pasteur settled that issue of whether things just spontaneously arise. And it was things like, I don't want to get too gross, but spoiling food, it gets maggots on it. They said it just arose from the food, right? Today we know that's not true. So he made a very famous statement, life only comes from life. Oh, we know that too well, right? But just think about it. For almost 2,000 years, humanity was not able to settle that question of how things came about, all right? And after he spoke about his experiment, he said that life is a germ, and a germ is life. Never will the doctrine of spontaneous generation recover from the mortal blow of this simple experiment. So one of the things to understand there is that, and when did this happen? This was like in 1864, thereabout. That's when he won the prize. And what is important to understand is around that era is when what we call the Renaissance, right? Rebirth was taking place, and there was a different notion of trying to understand the world. Experimentation became important. Observing. Back 2,000 years ago, in the time of the Greeks, they were called natural philosophers because they philosophized. There wasn't the idea that you should observe, you can experiment, right? These things that feel so obvious to us, it took thousands of years to be actually understood. They believed that I can think upon a problem and therefore I can solve it. Well, at this point, after our two stories, we know that thinking upon a problem is just not enough. So folks, we're going to take a break at this time as we ponder upon these blunders in science. I'll see you back in just a bit. Welcome back, right? Have you been pondering upon some of the blunders of science and now not feeling so bad, right? When we mess up and we feel very badly, oh, we've made this mistake. But here we've seen at least two examples of mistakes that humanity made and believed and persisted for thousands of years, right? One's first story was, what is the atom, right? What's the smallest part? And we know about the contribution from India, which was just overlooked for thousands of years. And then we saw the story of how does life arise? They didn't get that until so much later. So what's our next story? Are you ready for a third one? So listen out for my statement. I'm going to read it for you now. The balance of 4 bodily fluids, and giving you a little bit of hint, those 4 bodily fluids are black bile, yellow bile, phlegm, and blood, influenced the creation of some of Shakespeare's characters. Okay, you didn't see this going there, did you? Okay, so if any of you are interested in literature, there's a lot of work by Shakespeare, a very well-known author of plays, right? And he was around in about the 1600s, okay? So that's the clue I've given you. So back to the statement, the balance of 4 bodily fluids influenced the creation of some of Shakespeare's characters. Is that true or false? What do you think? What do you think? And what story does it cue? All right. Well, one of the clues is that Shakespeare was around in around the 1600s, okay? So we put that one side. The other aspect of it is that what was their understanding in the 1600s as to what gave us our characteristics, our personalities, and behavior, because that's what makes a part of Shakespeare's characters. Well, today we know, right, our personality dispositions, psychology, and things like that, right, our modern day studies. But back then, what did they believe in terms of our health and well-being? Well, folks, it was believed that all our mental health and physical health was due to a balance of 4 bodily fluids, right? And yes, they were known as black bile, yellow bile, phlegm, and blood. And how far back does the theory of 4 humors go? Well, it goes as far back as in the time of one of the biggest names in medicines, Hippocrates. If any of you, your children or family members are doing medicine, they have to take the Hippocratic Oath, and that's where it comes from. So Hippocrates was around, again, about 2,500 years ago, and he and other scholars suggested that all of health had to do with a balance between those 4 bodily fluids. So is it true or false? Well, it turns out the statement that I made is actually true, because in 1600, from 2,500 years ago, that's what they believed, okay? And it was, if you had a fever, you know, up till this day, they have statements like feed a cold and starve a fever. That's where its origin is. What you eat. And they would use things like bloodletting and observing the fluids, phlegm, right, and things like that that come out of your body. And if they were out of balance, that led to illness, right? Today we know that's not what modern day medicine is about. How is that for another blunder in science? And my blunders that I've brought to you, another lasted thousands of years, okay? So that's what they believed. And it was not until, again, you notice 1800s keeps coming back, the era of Renaissance, when they began to understand the germ theory, that what actually caused illness and what didn't. So it took a lot of debates and observing, but for thousands of years we had it wrong, okay? And Shakespeare's characters too. So your personality and everything was influenced with the balance of those things. Have you had a hot pepper recently? You ever wonder why it's called hot pepper? And things like that. So some of these are like remnants of very old from these theory of humors, of hot, cold, and dry, and moisture, and balancing it with the fluids. Okay, so I think we can get in one more story for today. All right, and let's see where we're going to go. And of course, the story had to do with, again, I could just leave it on Greece, right, on our world map, because that's where most of the modern day Western science owes its origin to. Right, well, you know, right, there we are in Europe. Okay, so one more statement. And are you ready for it? Okay. It was believed that the shape of your skull can determine your personality traits. Is that true or is it false? It was believed that the shape of your skull can determine your personality traits. What creates your personality traits? Has something to do with your brain, perhaps, okay? And we sometimes say your wiring, and your predisposition. The field of psychiatry and psychology tell us why and how we behave, right? But back then, okay, and this one is not 2,000 years ago, but just about 200 years ago or so, about maybe 250 or so, it was believed that the shape of your skull determined your personality and your behavior. Yes. Right? And it even had a name. The entire field was called phrenology. And they would actually, you could say it had a little digital aspect, right? Digits meaning fingers. They would actually feel your head for bumps, and based on the bumps and the shape of your skull, they will tell you if you are inclined towards music, athletics, if you were a quiet person, or one of a cheerful disposition. So, was that true or was it false? It turns out that it is true that several hundred years ago they believed that the shape of your skull can determine your personality traits. Today we call the field of phrenology a pseudoscience, meaning there is no merit to it. But interestingly, even pseudoscience and things that have been totally debunked did lead to some developments, all right? Because they studied the brain because they wrongly thought that the brain influenced the shape of your skull. Makes sense, right? So that's why the ideas went to in terms eventually as to how the brain influences who we are and what we do. Of course, it was all wrong. They believed that the parts of your personality that were reinforced, like the brain was like a muscle, and it got strengthened, and therefore it caused bumps on your skulls. But if something like that, and of course today we know it's absolutely not true, they could not verify it. They could not even agree upon how many organs, personality organs there were in the brain, all right? And they thought maybe 27, maybe 40. But eventually this was debunked. Another blunder in science, right, in terms of what gave origin to our personalities and what we choose to do. It's definitely not the shape of your skull. And sadly, there's a sad aspect to the story as well, because they used these ideas to promote things like racism and things like that. Even sexism, in terms of that women's skulls were differently shaped from men. Well, thankfully today we know that none of that is true. We've seen some very interesting blunders in science that have happened that lasted hundreds of years and thousands of years. So you're wondering, have we made any blunders in science in the recent era? What about in 1999 perhaps? You think we've made any scientific blunders? Well, how's this for a very recent, possibly one? But again, we start with our statement, but we don't know if the statement is true or false. Here we go. A mix-up of metric and English units, and by that we mean pounds and kilograms, we mean miles and kilometers, right? So those are the different types of systems, cost a Mars mission hundreds of millions of dollars in loss. Is that true or is it false? A mix-up of metric and English units like pounds and kilograms cost a Mars mission hundreds of millions of dollars in loss. All right, so what story is connected with that statement? It turns out, we were wondering, is there anything in recent times that may have caused a blunder? Let's see. So, as it turns out, in 1999, so that's just, 25 years ago, after 10 months of travel to Mars, one of the missions, right, called the Mars Climate Orbiter, burned up and broke into pieces as it was approaching Mars. What happened? But clearly a blunder in science happened. And what did it cost? Yes, folks, it cost hundreds of millions of dollars. What caused that blunder? Well, your statement there is actually true, because it was nothing more than a mix-up of metric and English units. All right, so you had two teams. You had the navigation team at the Jet Propulsion Laboratory, and then you had the team that was building the spacecraft. And one used kilometers and kilograms, and the other one was using pounds and inches. And when the teams came together and the software, that was not factored for. So when the probe went towards Mars, the answers, the acceleration and the deceleration it required just totally bungled up, and the your Mars Climate Orbiter blew up. How's that for a science blunder? So I think with that, we've brought you a couple of stories today of some of the big science blunders that have cost not just time and understanding and our health, but things that have cost us hundreds of millions of dollars. So folks, that brings us to the end of the episode today, in which we have looked at blunders in science, and we've seen that it has always not been a straight line path to the success point I'd like to say we are at now. We are in a space age. Everything is so highly technological, but it took a lot of mistakes lasting hundreds of years, thousands of years to bring us to where we are. So I hope you enjoyed the stories today, and look out for our next story next week as we continue with our series on stories from science. Bye.